Hi, welcome to SB Chem classes. Today we are going to discuss about an important section in equilibrium, that is solubility product. Solubility product, molar solubility, their relation and depends calculations. These are very important sections in our board exams and also in competitive entrance examination. So, what is solubility product? It is represented as KSP. Its representation KSP. It is simply equilibrium constant of partially soluble compounds or equilibrium constant of sparingly soluble compounds. We are giving one example, AgCl solid. If it is added to water, it partially dissolves in water to form Ag plus aqueous and Cl minus aqueous. So we can simply write its equilibrium constant. That equilibrium constant is Ksp. How we will write equilibrium constant? Concentration of product by concentration of reactant. So concentration of Ag plus into concentration of Cl minus. We don't want to divide by concentration of AgCl. Why? It is solid. Concentration of solid, concentration of liquid are considered as one. Another example, PbCl2 solid dissociate to form Pb2 plus aqueous and 2Cl minus aqueous. So its equilibrium constant Ksp equal to concentration of Pb2 plus into concentration of Cl minus raised to 2 because its coefficient 2, so it's taken as its power. Another example, MxNY solid partial dissolved X My plus aqueous plus Y NX minus aqueous. It is a general reaction. We know X is number of M. What will be charge of M? That will be Y plus. Y is number of N. What will be its charge? That is X. X minus. So this is the reaction. Its Ksp will be. Its Ksp will be concentration of M Y plus raised to X, concentration of N X minus raised to Y. This is the basic data we have to know about the solubility product. Since it is equilibrium constant, we already know it depends only on temperature. So Ksp of a compound, Ksp of a particular compound depend only on temperature. Next we are going to study about the molar solubility. Molarity means its concentration. We know molarity simply concentration. Solubility means it is amount of substance dissolved. So molar solubility we can define like this. It is molar concentration of soluble substance at equilibrium. What is the molar concentration of soluble substance when equilibrium is reached? So we can simply say that it is the maximum amount of substance that can be dissolved, because when equilibrium is reached, it will be its maximum value. So molar solubility is the maximum amount of substance that can be dissolved. That is when equilibrium is reached. Since molar solubility is the amount at equilibrium, we can relate it with Ksp. Because Ksp is equilibrium constant, so we can relate Ksp and S because both are calculated at equilibrium. We have the reaction AgCl equal to Ag plus and Cl minus. AgCl do not undergo complete dissolution. If 2 mole AgCl is dissolved, we will get 2 mole Ag plus. If 2 mole AgCl is dissolved, we will get 2 mole Cl minus. So concentration of Ag plus will be that S. What is S? It is the amount dissolved at equilibrium that will be equal to concentration of Ag plus. Then what will be concentration of Cl minus? That also S. We know its Ksp-S relation. What it is? Ksp equal to concentration of Ag plus into concentration of Cl minus. By substituting these values, we will get S into S, that is S square. So for AgCl, what is the relation between Ksp and S? That is Ksp equal to S square. This relation will be different based upon the compound. We can go through some examples also. Okay, it's another reaction. PbCl2 solid become Pb2 plus aqueous and 2Cl minus aqueous. If S amount of PbCl2 is dissolved, we will get S amount of Pb2 plus because 1:1. So concentration of Pb2 plus at equilibrium will be S. But if S amount of PbCl2 is dissolved in equilibrium, there will be double amount of Cl minus because 1:2. So concentration of Cl minus will be 2S. We know Ksp relation. What is Ksp? Equal to concentration of Pb2 plus into concentration of Cl minus raised to 2. We can substitute here Ksp equal to S into 2S raised to 2. So answer will be 4S cube. In this way, we can relate Ksp and S. But we can use a shortcut to relate Ksp and S. What will be that? PbCl2 is our compound. We have to relate Ksp and S. How many number of Pb here? 1. So I am writing 1S raised to 1. No confusion? How many number of chlorine is present? 2. So I am writing 2S raised to 2. So answer is 4S cube. In this way, we can simply relate this Ksp and S. We can go through another examples. Okay, let's go through these examples. Mx and y. I want to relate Ksp and S. How many M is there? X. So x s raised to x. How many n? Y. Y s raised to y. So we can relate x raised to x into y raised to y into s raised to x plus y. Another one. Z3p of 4 times. You can simply say that. Ksp equal to, say, how many number? 3. So 3s raised to 3. It is 4s raised to 4. By calculation, it is 6912 s raised to 7. So another example. Here, Cr of 4 is one species. Okay. So how many Ag? 2. So 2s raised to 2. And what about Cr of 4? 1. That is 1s raised to 1. 4s cube. Okay. So by this way, we can relate simply Ksp and S. So we have another example. Hg2Cl2. Actually, we have to focus this example because it has some exception. What it is? When Hg2Cl2 is dissolved, it dissociates as Hg2 2 plus and 2Cl minus. Hg2Cl2 dissociates as Hg2 2 plus and 2Cl minus. So Hg2 2 plus is one species. Hg2 2 plus is one species and there are 2 chlorines. So we can relate Ksp. How? If Hg2 is one species, it is simply 1s raised to 1. But there are 2 chlorine, 2s raised to 2. So answer is 4s cube. By this way, we can relate Ksp and S. To know more about the Ksp and S, I am explaining another fact. If AgCl solid is dissolved in water, it undergoes dissociation to Ag plus and Cl minus. And finally, equilibrium is reached. Why? It is have a reverse reaction. Forward reaction is known as dissolution. Backward reaction is known as crystallization. This crystallization also known as precipitation. What is actually S? It is the amount of substance dissolved when equilibrium is reached. That means, if for a substance S value is very high, that indicates more amount will dissolve. That means crystallization have less tendency. So I am focusing the point as value of S increase, we can say that it have more tendency to dissolve. Solubility increase, that means it have less tendency to crystallize. Crystallization decrease. So, as value of S increase, solubility increase, crystallization decrease, that means it undergo crystallization last. So these are the points we have to know about the molar solubility. Okay, let's discuss a problem, an important problem. Solubility product of AgCl is given 4 into 10 raised to minus 10. We have to calculate its solubility of AgCl in pure water, in 2 molar NaCl, in 0.1 molar CuCl. These are the 3 questions, very important question we have to know about solubility calculation. If we are considering pure water, there is no ion including AgCl. AgCl have 2 ion, Ag plus and Cl minus. There is no ion like that. So we can go through direct relation between Ksp and S. What it is? Ksp equal to S square. S is equal to root Ksp. What is Ksp? 4 into 10 raised to minus 10. So 2 into 10 raised to minus 5. Okay, there is no problem. But in this question, we can say that AgCl have 2 ion, Ag plus and Cl minus. It involves Cl minus, it involves Cl minus. So it have common ion effect. Common ion effect. We know Le Chatelier principle. According to Le Chatelier principle, as concentration of common ion increase, as concentration of common ion increase, S value will decrease. As concentration of common ion increase, S value will decrease. So, in pure water, we got S value 2 into 10 raised to minus 5. If there is common ion, we will get the value which will be less than 2 into 10 raised to minus 5. And we have to focus the point, as concentration of common ion increase, this S value will decrease. So, how we will calculate S value in these problems? Okay, we know about AgCl that undergo Ag plus and Cl minus. Concentration of Ag plus. I said, if S amount of AgCl is dissolved in water, there will be S amount of Ag plus. So concentration of Ag plus equal to S. There is no other Ag plus in this solution. Okay. If S amount of AgCl is dissolved, S amount of Cl minus will be formed. So concentration of Cl minus is also S. But in this solution, additionally 2 molar NaCl is there. From 2 molar NaCl, you will get 2 molar Cl minus. So totally concentration of Cl minus will be S plus 2. But we can say that S value in pure water is 2 into 10 raised to minus 5. In this case, the S value will be less than 2 into 10 raised to minus 5. So S value is negligible. So in this calculation, concentration of Cl minus is taken as 2. In this concentration of Cl minus taken as 2. Why it is taken as 2? S is negligible when compared with 2. Then what will be concentration of KSP? Concentration of Ag plus, that is S, into concentration of Cl minus, that is 2. So what will be S? KSP by 2. What is KSP? 4 into 10 raised to minus 10 by 2. That is 2 into 10 raised to minus 10. It is less than that in pure water. What is the value of S in pure water? 2 into 10 raised to minus 5. Now we got 2 into 10 raised to minus 10. Okay. Then we have to solve this problem. Okay. In this question, you have 0.1 molar CuCl and it have a KSP. That means CuCl do not undergo complete dissolution. Okay, so from 0.1 molar CuCl, we do not get 0.1 molar Cl minus. Why? CuCl undergo partial dissolution only. So first I am relating KSP and S of CuCl. What is KSP is equal to S square. S is equal to root KSP. That is 10 raised to minus 6 root 10 raised to minus 3. So very important, you have to focus the point. You have given 0.1 molar CuCl, but there is no 0.1 molar Cu plus or 0.1 molar Cl minus. There will be 10 raised to minus 3 molar CuCl dissolved. So concentration of Cl minus from CuCl is this 10 raised to minus 3. Concentration of Cl minus from CuCl is 10 raised to minus 3. So we can go through AgCl. Its concentration of Ag plus equal to S, not out. Its concentration of Cl minus also S, plus we have to sum the value 10 raised to minus 3. In this question again, S value is negligible. Why? S value in pure water is 2 into 10 raised to minus 5. In this question, answer will be less than 2 into 10 raised to minus 5. That will be negligible compared to 10 raised to minus 3. So it is 10 raised to minus 3. Okay, then KSP equal to for concentration of Ag plus yes, for concentration of Cl minus 10 raised to minus 3. What is KSP of AgCl? That is 4 into 10 raised to minus 10. So S is equal to 4 into 10 raised to minus 10 by 10 raised to minus 3. By dividing, we will get 4 into 10 raised to minus 7. This is a very important question because the problem is that in question there is 0.1 molar CuCl, but that 0.1 cannot be taken as concentration of Cl minus. Why? It do not undergo complete dissolution. So from its KSP, first I calculate molar solubility of S. That S can be taken as its concentration of Cl minus. By that concentration of Cl minus, we calculated molar solubility of AgCl.